Hello. In this video, we will discuss more about collision avoidance technique. In the last session, we have studied about CSMA-CA protocol and the operations that are carried out during CSMA-CA protocol. Also, we have seen that there are handshaking signals which are exchanged between source and destination. Those handshaking signals are known as RTS, request to send, and CTS, that is clear to send. In this diagram, you can see source initially waits for DIFS time and sends RTS signal. After waiting for SIFS time, that is short interframe space, destination replies back if it is ready to receive the data. Then actual data will be sent, and again after waiting for SIFS time, acknowledgement will be sent back by the destination. When this communication between source and destination is going on, what all other stations are doing? It is possible that one of the other stations wants to send the data exactly during that time. So if that station tries to sense the channel, it is busy, or when the station suppose sends the data immediately without sensing the channel, obviously there is going to be a collision. So when one pair of source and destination are communicating with one another, other stations are also informed, and in such a way that during that time no other station will even try to sense the channel. And this mechanism is known as NAV, which is known as network allocation vector. So NAV is nothing but a timer which is used to estimate the time for the communication between source and destination. When source sends RTS, along with RTS, it sends the estimated time for the communication from source side. Similarly, CTS also contains the duration for which the communication will be going on. Now, from this duration, all other stations will set their timer exactly equal to that D, which is sent by source and destination. And for this much time, which is shown in a yellow color on the slide, for this much time duration, no station will sense the carrier they already know that one pair of stations is communicating with one another, and even if I try, I might get the outcome as this channel is busy, or if I directly send the data is going to collide with someone else's data. So using this NAV, the collisions can be avoided. I hope the idea of network allocation vector is clear to you. It is a timer and it will be set for all other stations depending on the duration which is informed by the source, that is equal to estimated time for the communication. And when the timer is on, no station even tries to sense the channel. When the timer is over, when the communication is over, the timer or NAV will get over. Once that is done, then the stations are free to sense the channel again. So that is about NAV. And now let us discuss about repetition interval. In CSMA-CA, we have seen that the condition which is set is PIFS less than DIFS when access point and station wants to send the data at the same time. In that case, obviously the priority is given to the access point, and if it happens, stations might not get the chance to send the data, or stations have to wait for a longer period when access point is done with the data sending. So to avoid that, or to accommodate the data from both stations as well as from access point, a period called as repetition interval is used. Now if you look at the diagram, this repetition interval comprises of contention free period and contention period as well. So in one repetition interval, we have two types of periods, contention free period and contention period. Obviously, contention free period is used by the stations or the network components which are using contention free services, and that is nothing but access point. So when access point uses PCF, that is polling access method, then that is called as contention free period, and by the end of this, contention period will be entered by the station, where stations that use DCF can communicate or compete with one another using some random access protocol. So what happens in this contention free period? Initially, access point waits for PIFS time, then it sends B. B is nothing but a beacon frame, which is the initial frame which indicates that access point is starting with its polling method now. So when beacon frame is on the channel, other stations will start their NAVs, right? This contention free period uses polling access method, and so access point keeps on polling the stations, and stations which are being polled will send the data. This continues for a while, and by the end of contention free period, CF end frame is sent over the channel. CF stands for contention free. So when this frame is on the channel, stations will stop their NAVs. Now they are entering into contention period, and in contention period, any station without any priority can gain the access of the channel by using random access protocols. So using this repetition interval, there is accommodation for contention free period and contention period, and so traffic from access points and traffic from stations equally get the chance to send the data. So this is very important concept which is known as repetition interval, which is used in wireless LANs. Thank you.